I don't know. What are those actually fairies here?
Ah, don't be ridiculous. There's no such thing as fairies. Ah. Nothing happened. Like I said, fairies aren't. Who's down? Who's down? Stop it! You broke my triangle!
Really? That's it? Where's the rest of you? You look like a head. Your mom kicked you down the stairs or something? Didn't get enough milk?
One chance! Mr. Bonebrain.
Well, yeah, but I'm not really feeling it today, so... Alright. Show me what you got.
Round 1. Fight!
Before that fool broke my triangle, my master told me that side AB can be modeled with the equation y minus 1 equals 2 bracket x plus 7, and BC can't be modeled with the equation y equals negative 1 divided by 2x plus 2.5 before they had to go to their philosophy appointment. But they didn't tell me how to find the other side before that buffoon broke it. And I can't figure out how to find it either.
Okay, let's first take notes of the points A, B, and C. Now, let's put the triangle on a graph with their points' respective equations to help us determine the missing side and for further visualization. As we can see, we have the equation for the points A, B, and BC, but looks like the equation for the line AC is missing. Let's fix that. In order to create an equation of a line segment, you need... With that out of our way, we can now go over how to find both requirements to find the equation of a line. First, how to find the slope of a line. The equation to find the slope of a line is where before plugging the values in, it is very important to know which point is x1, y1, and which point is x2, y2. How you can figure out which point is which is by... Let's bring back our graph to see which point is highest on the y scale. By looking at this graph, we can clearly see that the point C is the highest on the y scale than point A, and so... Now, so the slope of AC is 1 over 3. Now, pick a point on the line. Personally, I pick point A because an equation that is given to us already has it, equation AB. With that, let's go over how we'll turn this equation. Since we now have, this allows us to make an equation via point-slope form. Equation form that uses a single point of a line and the slope to create the equation of a line. The equation is where now, yes,
I'm confused. Why does minus y1 and minus x1 get turned into the opposite sides?
oh, let me explain. If I were to put them in the existing formula of, it would look like this. Pretty simple, right? However, when it gets to two negative signs together, it doesn't get a bit more complicated. You see, two negatives make a pause step. Thus, this will be... To make this easier, you can just remember to switch the signs for y1 and x1 in the point slope form. Thus, with that all done, put the answer for what the equation for side AC is. So, let my friend go, or...
Not quite.
Round 2. Fight!
My master emailed me that the perpendicular bisector of A side AB is x plus 2y equals 0. They told me in the email to find it myself, but, well, apparently I found it wrong, and they told me to figure it out because they had their philosophy appointment is scheduled to take all night.
Show me your work. The steps for finding a perpendicular bisector of a line is... Let's go over what went wrong with the original answer. Let's go through the question with the new answer to see what went wrong. The equation to find the midpoint is... A quick note, when writing down the midpoint equation, we should use the uppercase m, not a lowercase m. This is because while the uppercase m represents the midpoint, the lowercase m represents slope. Anyways. Looks like something went wrong. Let's break it down and see what it was. Oh, it looks like they switched x1 with x2 and y1 with y2. Seeing that I used the midpoint 4 minus 3 for the rest of the problem, they got the whole answer wrong. However, we can still check if they've used the right process by solving the problem side by side with the new midpoint. But first, let's do the second step. Find the negative reciprocal of BC. The negative reciprocal of the side means that the slope of the line will not only be reversed, but the sign will also be reversed. Just in case you're confused, let's go over why the negative reciprocal is like this. This is a perpendicular bisector, with perpendicular meaning 90 degrees, and bisector inducing the idea that there is a line that goes through the midpoint. Since the line is at a 90-degree angle, you know that a line will have the opposite everything. We call the slope of this line the negative reciprocal of the original line. Let's find the negative reciprocal of BC. The negative reciprocal of BC is 2. Let's continue on our last step before we can do step-to-step solving next to the original answer. Make the equation. From the first problem, recall the point slope formula. Now place the midpoint and negative reciprocal into the correct spots of the equation. And with that, we can go back to side-by-side solving. Something is wrong with the original answer. 8 minus 3 does not equal 11. 8 plus 3 does. Thus, the original answer's proper answer is... But the real answer is... Now, can you let my friend go?
Not quite.
Final round. Fight!
My teacher told us that we'll get extra credit for finding the radius of the circle. Enter and we find out what equation of the circle will be in this circle was translated so the center was moved to the origin. I thought I could never get this credit, but with you, I guess I might get it.
Okay, let's do this. The circumcenter is the point in which all the perpendicular bisectors of a triangle meet. This is also the point in which the circle can be drawn around it, with each perpendicular bisector having a point on said circle. Let's break this up into steps. Step 1. Find the circumcenter. First, let's go over what we do know about the perpendicular bisectors. BC's bisector tells us that y equals 2x plus 10. It's because of this we could insert 2x plus 10 into AB's perpendicular bisector, which does have the variable of y in it. By doing this, we isolate x, thus finding the value of x in the intercept of these two equations. Now let's solve this equation. Now that we found x, we can substitute x into one of the equations we have to find the y value. Personally, I picked the equation y equals 2x plus 10 because this equation is already set to equal y. Thus, the circumcenter of ABC is minus 4, 2. Before we move on, let's check if the circumcenter is the real circumcenter. We can do this by using the equation we found in the first problem. But before we check, we have to make sure everything is equal to y, turning this point-slope form into slope form. With that, we can substitute the x value we found into this equation to see what y equals. If it equals the y value we found, then we know our circumcenter is correct. Since y equals 2, the value we calculated earlier, this confirms that our circumcenter is correct. Now let's move on to step 2 of our solve, find the radius. The radius of a circle is the distance of a line from the center to any point on its edge. With this definition, we now know that we need the circumcenter we just found and a known point on the circumcircle, something that we'll get to later on. To explain further, let's draw a diagram. This is a triangle diagram that has been featured before in the first problem. But what would happen if we draw a circle around the vertices of this triangle? Well, you would create something called the circumcircle. Notice how all existing points of the triangle has a place on its edge. This is how we will find the point on the circle's edge. Now let's go over the center of the circle. The center of this circle is called the circumcenter, something that we have already solved for but not yet seen in the diagram. Let's fix that. A line that perfectly lands in the meeting point of the two other lines. Now without all width, let's find a point that falls on the edge of the circumcenter. Since all vertices fall on the edge, we can just pick one. Personally, I picked point A. The perpendicular bisectors we found now in the circle, bisectors A and B, where they meet is on the circumcenter, the center of the circumcircle. While we don't find all the perpendicular bisectors of BC together, if we did, it would look something like this. And let's go to the formula we will use to find the distance from circle center to point A, the distance formula. Remember, all of these have the same values that we have gone over in past problems, with the same way to determining them. All we gotta do is plug in the values of. Now let's plug them in. Since square root of 10 is an irrational number, we leave the answer as it is, and so. Alright, so last part of the extra credit work. Find out what the equation of the circle would be if it is translated to be moved over to its origin. If the circle is moved to the center of origin, the following equation would take place. With, remember, all these values are squared. Since the x and y values are at the origin, 0, 0, these values stay as they are. However, thus, the answer is x squared plus y squared equals 10.
Fatality.